till up to about 2010, when I said to people I was working on climate change as a sociologist, natural scientists were asking me what the hell I was doing there, because climate change was all about molecules in the upper atmosphere, and sociologists do not ask questions to molecules. And my fellow friends and sociologists were wondering why I was working on this, since climate change was an issue of molecules in the upper atmosphere. And so I didn't understand why there was this misunderstanding on their part, since natural scientists, even in 2003, if you look at the IPCC reports, were telling us, well, no, climate change is probably, and now it's quite certain, that it's caused by human activities. Well, if you talk about human activities, we're talking about social sciences. We're not talking about natural sciences. So I did not understand why they did not understand why I was there. Things have changed a lot since then. The first work that has been undertaken by social sciences on the issue of climate change was about mitigation in different sectors. We were much more comfortable with the idea of working on mitigation measures, because actually we're talking about human practices. We're talking about mobility, we're talking about daily consumption, we're talking about how you're cooking, how high your temperature and your air conditioning is in the summer, and so on and so on. I just finished, by the way, just a little bracket, I just finished a really large survey in Monaco. We asked people what was their heating temperature in the winter and what was their air conditioning in the summer. There were only 2 degrees difference. Okay, 20 in the winter and 22 in the summer was the average. So you can actually wonder what that may involve in terms of energy consumption in the summer. I'll get back to that. What I would like to talk about today is what climate change has done to our understanding of risk. Some of you might understand that quite well, but I also want to talk about how social sciences have dealt with, managed, understood, brought some new light on the idea of risk as well. Okay? The first thing that climate change did to risk is that before climate change, we looked at risk as something from the past. We learned from the past, and we know that every 10 years, this river is going to overflow. Every 50 years, there's going to be this, and every 100 years, you know. And we can even see this historically in construction of bridges, for example. Digs, the way a village is constructed around a river, why the center tower is not there, but rather a bit higher up. Well, there are good reasons for this usually. In other words, our conception of risk was first quite objectivist in the sense that it has real effect, and the social sciences were not there to say, well, there's a subjective part to risk as well. I'll get back to that. I'll give you some really strong example of how important subjectivity is in risk assessment, in risk understanding, or non-assessment and non-understanding. That's really important. One of the things I work on a lot is, I would say, the drivers of behavioral change and institutional change and non-change. You need to understand that not changing is not being passive and sitting on your chair and not moving. There are strong factors, forces behind not changing. Okay, very dynamic forces that lead us to not change. And if we don't understand that, we're missing the point. And so I'll give you a few examples of this as well as I go along. So the first thing that climate change did was to say, and the natural sciences were quite clear on this, climate change is not a risk as such. It will, and it's already amplifying already existing risks. So storms are going to be stronger than before. But they're also moving. I had a really weird experience 2 years ago. I went to Quebec, my home country. We just landed at the airport, and we're just coming out, and suddenly all the phones are going beep, 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 beep. All of them at the same time. It was an emergency warning from the government telling us there was a tornado warning in Montreal. Tornado in Montreal. That is not supposed to be possible. Well, I tell you, the next hour in the bus, with the tornado coming behind us and the bus trying to get out as fast as possible from Montreal so as not to get involved in the storm, with a 1-year-old baby, it was quite a lot of fun. What climate change is doing is not creating tornadoes, but it's moving them into new places that may not be built to resist tornadoes. So risk has become, with time, more and more human-based. And this is how the social sciences got into it. So this is a really, really important part of climate change. And it leads to some confusion. So the first thing that climate change does is to bring us to a different view of risk. Risk is not based on the past. It's based on scientific projections on what could be risk in the future, according to a certain level of degrees increase. If we have plus 2 degrees, 2.5, 3, 3.5, in 2050, actually the risks and the changes brought about by climate change on rainfall, on droughts, on how the snow melts and so on, are going to be different. In other words, in order for me to be prepared to a new situation in 2050, and this new situation in 2050 will not be fixed, it will not be stable, it will still be changing, well, I need to prepare now. And in order to prepare now, I need to have an idea what's going to happen later. Okay? So that has brought a very different way of looking at risk, which involves as well, I'll get back to that later, political risk on what I'm doing now in terms of adaptation measures on my territory, in terms of diversification of my economic activity in high altitude mountains stations, ski resorts, and so on and so on. What do I do? And so on. So I'll get back to that because it's a really, really important point that social sciences are really brought forward, I think. So first effect, you need to project yourself forward. So you need science to do that. You need to have an idea. The first mistake we made was to talk average. It is a mistake. For years we said, on average, in 2050, there will be more or less rainfall, blah, blah, blah. On average, in Quebec, there will be more snowfall because it's slightly less cold, so it's more humid, so there's more snowfall. But on average. We realized in the last few years that average is not interesting to practitioners and operational people who are working on adaptation. Who cares? I'll give you an example. We did a projection of rainfall for the Grand Dijon in France. And on average, science told us that rainfall would be just about identical in 2050 with a plus 3 degree increase. But by looking a little more detail, we realized that there would be a lot more rainfall in May and June, no rainfall in July and August with a lot of heat waves, and more rainfall in September and October. And that is really, really important for health, and it's really important for wine. The Grand Dijon is a really big producer of high-quality wine. And the amount of rainfall and the heat waves will have a great impact on the quality of its grapes. That is important, not the average. So I've noticed in the last few years that often natural scientists are now offering not average, but extremes. Practitioners need to know what the potential extremes will be in order to manage these extremes, because those are the crisis point. Those are the risks, not the average. Okay? So that's a first important point. Second important point for me in terms of risk, it's not because a risk exists that it is important for you. Maybe you don't even know it exists. And even if you know it exists, it doesn't mean it will have an impact on you. You may also think that the risk is really important, but scientifically it's not. That's when we talk about subjectivity. One of the first examples that I love giving comes from Céline Lutoff right there, who I remember about 20 years ago when we first started working together, told me about this example. If I remember correctly, you were making a study of people wanting to cross a small river by car to get to a campground. And there was a sign saying if the light is red, don't cross, it's dangerous. And people would look at the red light, and cross anyway. This is an immediate risk. It's not a forecasted risk by some natural scientist, part of the IPCC, the United Nations. This is the real risk now. It's visible. There's a warning sign, but I'm still going anyway. That got me thinking a lot. And a few years later, I fell upon a meta-study on risk and how people perceive it during catastrophes. We're talking about train catastrophes, boat, planes, avalanche, and so on. And the meta-study, I'm going to go forward. I'm not going to talk about the method here. Came up with 3 categories of people, with one category surviving better than the other 2. Faced with a real catastrophe. The first group, I love that example. You have 2 old guys playing chess in a park. And there's a plane coming, crashing, and coming right over their heads, about 50 meters, fire going and so on. And the 2 look at the plane and go back to playing chess. The ostrich syndrome. Which the ostrich does not do because they would have been extinct. But the idea is to deny the risk, deny the danger, because your brain just thinks this is not possible. Okay? It's just too much cognitively important, powerful for the brain to deal, so get back to chess. The second reaction is like, sorry for this example, but I lived on a farm for a while. You take a chicken, you cut the head, and you leave the chicken moves for a while. Part of the population, a certain percentage, we actually act like this. We actually going to run into all kinds of direction. The lucky ones, not the ones who took a right decision, the lucky ones will go in the opposite direction from the risk, and so survive, and the other ones will die or be injured. There's a third group that tends to survive, and though that group, got a lot of attention. Why do some people survive? And they realize that often there are people who work in high-tension jobs. Firemen, policemen, doctors, people who actually have a brain who is trained to actually deal with that kind of pressure and that kind of tension. And even if it's not their normal everyday life, the plane crash is nobody's everyday life, the brain is still better trained to deal with it. But there are other people who actually didn't have a job like this. They had just a computer job or sitting like us researchers at a table not doing much. But they were doing probably a sport, an activity like climbing, rock climbing, that actually brought their brain to be trained for that as well. So there's a psychological makeup that's really important here. But all these little studies, or the meta-studies, showed us that the way you perceive risk and the way you perceive climate change risk and future catastrophes makes a whole lot of difference on how you deal with it now, and whether you will actually launch an adaptation strategy to deal with the risk on your territory. I'll give you some examples of this, because what I want to talk about is not the legal aspects of it. I think you understood that. It's the social and the political risks involved. The first political risk that is involved is the following. You decide that you've looked at all the studies, and you think that maybe you should start diversifying your economy, because in 20 years or 15 years, you won't be able to actually attract as many tourists in the winter, for example. But if you start doing that now, there are a lot of economic actors. The whole territory is living thanks to money brought from with the snow, with ski. It's just an example, there are others. And so what do? If you create social conflicts and debates and people who are not happy, you may not be re-elected the next time. There might be a scandal. And so how do you deal with that? The political risk is the electoral one. But not only. The elected officials that I've worked with always have that in mind, but it's not always important. Elected officials, depending on the country, whether they're elected or not, but in France, for 5 years, the second year, you're not thinking about re-election. You're just thinking about working. But that doesn't mean there are no political risk of scandals, of conflicts, and one of the major sources of conflicts, and that's when I want to get into even more important socioeconomic risk, is that if you put into action an adaptation measure that has negative effects on inequalities, you increase inequalities by your measures, then you create political risks as well. But you also create a sense of injustice and increase resistance to change. So that doesn't work. It's one of the reasons why now the notion of maladaptation has come to integrate this idea of social inequalities. You cannot increase inequalities by trying to deal with the risk. The problem is that the large studies and meta-studies show well that the poorer people are the ones who are the most exposed to risk because, well, land is cheaper, rent is cheaper, where there is risk, so it means that poor people can live there and that middle class and rich people can live where it's safer. So there's a direct interaction and cross action here between inequalities, poverty, and exposure to risk. Okay? When you deal with on the ground with practitioners, one of the first issues, one of the first obstacles we meet is subjective risk. Why the hell should I start having put any effort into adaptation strategy and dealing with future risk, which I do not feel yet, which I haven't seen yet? Yes, scientists are telling me that these risks are coming. They're going to be higher and more important than before, but I haven't seen it yet. And so this idea of having this projected cognitive, rational, and quite abstract risk is not sufficient reason to put into action now, something that may have negative effects. Okay? That's really important. So those are a bit of the bad news, why people don't want to deal with risk. There are subjective issues and there are objective ones. But not only. There are some interesting actions being taken by different, even companies, local public authorities that deal with risk. 2 examples of this. The first one is a city, I was talking about the Grand Dijon earlier, who didn't want to have too much information on future risk linked to climate change because it would give the city a bad image in terms of its political strategy. So they remained really on very simple stuff, on heat waves and urbanization, and so on and so on. The political risk here was not a risk for the elected officials, but the image they wanted to project to other cities and even to the world. Okay, so that's another example. In other cases, we do have territories that are really interested in adaptation. They want to be innovative. They want to take risk into account, but they're not too sure how. And in a recent study we did again with Céline, we asked people in France who were in charge of adaptation strategies, well, what do you need in order for you to go forward with your adaptation strategy? How will you handle the climate change risk? And most of them, they didn't tell us, we need more science. Actually, no, they need more operational tools on how to do that. They need help